Okay, question 9. I'm sure you can get the answer. Most of you should be able to get the answer, but I just want to say one thing. Actually, the intent of the question is that the acute angle between L and M, because it's understood when we find angle between two lines, maybe add this word in. If the acute angle between L and M is 60 degrees. Now let's start. If the question says that the acute angle between L and M is 60 degrees, there is only one orientation that it can be, This is L, this is M, this is 60 degrees, this is 120 degrees. Just like that. It's only like that. Now, I want all of us to distinguish between finding angles. I need you to distinguish between one angle between two lines versus angle between two vectors. Now in this question, the question says that the angle between L and M, which are two lines, is 60 degrees. And acute angle is 60 degrees. I'm sure you all know how to do this because everybody would have done it. Cosine theta is this. 1, 2 minus 1 dot 5a5 over root 6 root 50 plus a squared. Everybody would have done this, and you would have said that theta is 60 degrees. My point is this. The most important thing I want you all to take away from question 9 is this. Distinguish between finding angles between two lines and two vectors. You have done by writing it like that. You are finding the angle theta between two vectors. 1, 2 minus 1 and 5a5. Now, 1, 2 minus 1, then you will say same one, they are the same. Finding angle between two lines and finding angles between two vectors are the same, but I would disagree because finding angles between two lines, finding angles between two lines is like that. Finding angles between two vectors is this. You may say, 1, 2 minus 1. Could be this, and 5a5 is this. Now, if it so happened that 1, 2 minus 1 is in this orientation and 5a5 is in this orientation, you take cosine theta, you would realize that theta is 120. But even if theta is 120, you would still conclude that the angle between L and M is 60 degrees. Okay? I say one more time. Even if the orientation between the angles, the vectors here and here is like that, you will conclude that theta is 120. If you conclude theta is 120, eventually you will still conclude that the angle between the two lines is 60. So, I'm sure most of us would have said, theta must be 60 degrees. I caution this one first. Let us work this out first. This is 2a over square root 6a squared plus 300. Yes? Now then you say, okay. What do we say? We say theta equals to 60 or 120. Why? As I said earlier, your orientation of the vector could be like this. Or, if you are lucky enough, then it could be like this. If it's like this, then you happen to get 60. Fine, well and good. But you must consider the chance that actually your 1, 2 minus 1 is this way. Or this one is this way. You don't know. You really don't know. So, you say cosine theta must be plus minus half. At this point, then we say, okay, by chance, because look at the right-hand side expression here. The question asks for positive value of A, and A is positive. If a is positive, the denominator, of course, because it's square, always positive, cosine theta will never be negative. So therefore, since a is positive and square root 6a squared plus 300 is also positive, then cosine theta must be half. That means you have half over 2a over square root 6a squared plus 300. I think the rest is easy for most of us, but never mind, let's complete the thing. 4a, no square, sorry. Then you square both sides, you get 6a squared plus 300. Yep. Then you get a equals to square root 30 because a is positive. So I just want to emphasize this one more time, that you must include this idea that theta must be 60 or 120 because of this case. Please copy it down, please note it down. If you are unsure, then we'll go through it one more time. Okay? Thanks.